Welcome to NeuralCraft. This is the continuation of our second tutorial in our machine learning hands-on with Python playlist. So in tutorial 2 we had covered data visualization and we have specifically covered univariate plots. There are basically three major types: histogram, density plots and Bott and whisker plots. We have studied all these histograms, density plots and Bott and whisker plots in detail and implemented in our previous tutorial. Today we are going to do the implementation and understanding of multivariate plots. So as the name suggests, here we are going to be involved with more than one variable. So we can find out the relationships between the attributes, how they are changing with respect to each other. So there are two main types: correlation plot and scatter plot. So we will discuss them one by one. First one is the correlation matrix plot. When we find out correlation between the two attributes from the set of many attributes, then when we try to plot the graph, what the graph or the matrix that we get is known as the correlation matrix. So there are two main kinds. One is the positive correlation, another is the negative correlation. Positive correlation suggests that the variables are changing in the same direction, and the negative correlation suggests that the variables are not moving in the same direction. Either they are moving in the opposite direction or at some angle greater than 90 degree. We will see this when we will understand this more when we are going to visualize with the help of plots. So let's jump into our editor. So this is our editor, and I am just going to import these two libraries and our data, and then I have created one separate section known as multivariate plots, and now we are going to use correlation matrix. I'm going to import two major libraries. One is the matplotlib, basically pyplot method, and another one is the Seaborn. We are going to implement these plots with the help of both these libraries one by one. So first, using the matplotlib. For this we are going to create a color axis, and the intensity of the color is going to tell us whether these variables are positive or negatively correlated. So for this we have to write figure plt.figure, and now we have to create one axis. As you can also see this in the suggestions, add subplot 111, and now I am going to create color axis. Color axis is going to be ax.matshow, and here I have to pass on the correlation values. Now I haven't calculated the correlation values so far, so let's calculate them. Correlation is equal to data.core. We have already used this method earlier, and now we are just going to use it again. So correlations, and vmin and vmaximum and vmin are the maximum minimum values for the correlation that we want. These are just going to specify you the range. So here we are now going to get the color bar. This is going to be figure.color bar CAX, and now we are going to create the tits. These are going to just place on the they are just going to tell us about the which attribute is on where on our matrix. So this will be implemented with the help of numpy only, numpy.arange, as and it is going to be in the range of 0/9/1, because there are going to be 0 to 8 attributes in our data set, and we are using them. So ax dot set at tits, this will put the tits on the x-axis. Similarly, ax dot set tits y tits for the same tits variable, and now we are going to give them the variable names. So ax dot set tits, let's do without this, and now we are just going to plt dot show. So here we have got the kind of matrix with color labeling, which is going to help us tell which variable is how much correlated with the another variable. In the right side there is a legend which says with the color with the dark purple color shows a negative correlation, and yellow color shows a high correlation. So you can see this 7 and 8 are this 7 and 0, they are showing the green color which is around here, so they have a correlation between 0.5 to 0.75. Meanwhile, if we try to find out a negative correlation, this color here, this is around minus 0.25, 0 to minus 0.25. So this here it is showing a negative correlation. So now to make it more clear, now we are going to implement this with the help of Seaborn library. Seaborn library is another powerful library with the help of which we can perform data visualization. So here we have to just write one simple function sns dot heat map, and we have to pass our data correlations, and now annotation, we have to do this annotation is equal to true, and then our format will be for the variable values to be for 2 decimal places, and color map we are going to use this simple default color map. You can use anyone which you want. Now just we need to plt dot show. So as you can see, we have got the values arranged in the form of a matrix, and we can also now see the numbers. What is the exact value of the correlation? So as we saw, I said between 0.0 to minus 0.25, and we have got this value here. This is the correlation between age and skin thickness. So as age increases, our skin thickness decreases. This is what meant by this database. So also we can see a high correlation value. Let's find a high correlation value here. So here we are getting a 0.54 of 0.54. This is the, I think this is the maximum correlation we can find here. So this is between the pregnancies and age. So now we are, this is all about the correlation matrix, and now we are going to move toward the scatter plots. Scatter plot shows the relationship between two variables as dots in the two dimension, one axis for each attribute. We can create scatter plot for each pair of attributes. Drawing all these scatter plots together, we get a scatter plot matrix, and we can do this in two ways. One with the Pandas inbuilt scatter matrix function, or with the inbuilt function from the Seaborn library. First of all, we will use Pandas library function, pandas dot from Pandas. We have to write from Pandas dot plotting import scatter matrix, and now we have to pass in our data frame to our scatter matrix, and then we have to just plot it. You will see we are going to get one very big matrix in which the diagonal is going to contain the histogram plots which we had already visualized in our tutorial 2 part 1. Here we can see the plot is between each and every possible pair, so it is very difficult to visualize in this manner, so we are going to use Seaborn library. So we have to write sns dot scatter plot, and for the x-axis we have to pass in the exact name as per the column. So before writing, I am just going to do one thing, data dot columns, so that we get the names of the all the possible variables. So one variable is x-axis, one is going to be on y-axis, and then we have to pass in our data. These are the three important one, and then we have to do plt dot show. So first of all, we are going to find out the we will go as per the matrix. So here you can see okay, the names are also not visible, so let's just start PNC from here only. So one variable is going to be pregnancies, another one is going to be glucose. First see the relationship between them. Oh, we have, okay, accidentally I have just placed two variables, same variables on both axes, and you can see this is the identity function. All the points are in the one line. Now I am going to place here glucose. Let's see what is the relationship between them. As you can see, it is not showing that much of a direct movement. Although you can see one pattern that it is going like this one, this method. There is some slope in the data which shows some little correlation between them. If we check, go back and see the correlation between them. So the correlation between uh, pregnancies and glucose. So here we have pregnancies and here it is showing a 0.13. So it is a not a very good correlation between these variables. Let's use another pair. Let's see the variables which have high correlation value. So 0.54. This is between pregnancies and age. Let's see what is the scatter plot for these. So you can see the age and pregnancies are showing somewhat around following a y is equal to x axis, y is equal to x relationship. Although it is not that much good because we have only a 0.5 of correlation. If we had any correlation value around greater than 0.8, then this would have been more uniform. But here, since we are only having 0.54 as the highest correlation, all such curves we are only going to get this kind of image only. Here you can also see here it is showing almost a constant value. With change in one variable, the y-axis variable, the x-axis variable is not changing that much, or you can say the y-axis variable is constant. So this shows they do not have anything much in common. So when you have data which is processed already, like this diabetes data set, this is not a very real data set. I think this data set is prepared to just let you know how machine learning, different parts of machine learning work. So this is a very clean data set, but there are many cases, and almost every case in a real data we are going to get those attributes which are going to have large correlation. Maybe you will have almost if you have like 50 variable, 50 attributes, you may find some attributes in them which are showing a high correlation. In that case, you have to remove or drop one of the attribute, because otherwise you are going to pollute your data, and your model which you are going to train will be overfit, or it will go and it is going to give you false accuracies. So this is all about the plots that are needed in classical machine learning for a beginner who just want to like start understanding the data and start building the models. In the later sections, we are going to come up with the more tutorials for data preparation, data pre-processing, and these are going to play a vital role in them, because now we have seen this data on the top of it. Now we are going to perform feature extraction. After the feature extraction, what we are going to do, we are going to create basic machine learning models. So this is the path which we are going to follow in this machine learning playlist. So this is all for this tutorial. Thank you.